Good afternoon, everyone. First of all, I would like to thank you for joining today's webinar on a Thai researcher's journey to becoming one of the world's most influential scientific minds. I'm Kwan Chin Yap. I'm the marketing manager for Southeast Asia, and I will be your host and the moderator for today. So I'm joined by a few colleagues. I will introduce each of them to you shortly. They will each cover different aspects of exciting agenda that we have lined up for you. But before we get started, just to help you maximize your time with us, there are a few housekeeping outlines that I just want to go through. Now, first of all, this session is recorded. You can view it on demand anytime or any day after the event. Now, your microphone is muted by default for a best experience. And this webinar will only run on internet audio. So if you have trouble hearing us, do use the chat box function to type to us. Or if you you want to actually raise some of the questions on the topic to presenter, please use the Webex Q&A box. Now, let me introduce you to my first colleague, Anamika Charasha, who will make the welcome remark. She is currently the Senior Director of Academia and Government Division at Clarivate for South Asia and Southeast Asia. Over to you, Anamika.
Thank you, Kwanchin, and a very good afternoon, everyone. I extend a very warm welcome to you today on behalf of Team Clarivate. Clarivate is a partner to over 9,000 government departments, research institutions, academic organizations around the globe across the various stages of the research lifecycle. Our vision at Clarivate is to improve the way the world creates, protects, and advances innovation. My colleagues and I am working very hard to bring together our portfolio of products into a very powerful, integrated research intelligence value proposition that comprehensively covers the research workflow. Today, we are delighted to cover a very pertinent theme, which is creating great interest in the research community around the world. It is not only important to researchers, but it is also very much featuring as an important agenda item in the government policies. The theme is of biocircular green economy. Biocircular green economy focuses on a variety of things, including renewable biological resources, reusing and recycling materials to maximize the value, and to keep economy, society, and environment in balance, leading to a very sustainable development. We will feature a very impactful researcher, Professor Soottawat, who is a multi-year, highly cited researcher who has demonstrated significant and broad influence as reflected in his publications of multiple highly cited papers. Clarivate solutions can be very important enabler of insights on biocircular green economy. Please do not hesitate to reach out to one of the team members to inquire more on how Clarivate can help in supporting your objectives towards the BCG economy or any other theme for that matter. We will share their contact details at the end of the Q&A session today. Julian will also briefly cover some of the important use cases before we delve into question and answers with Inbeng and Professor Soottawat. Without further ado, let me hand it over to our moderator, who will then invite the first speaker in. Over to you, Casey.
Thanks, Anamika. Yeah, so before we go into our main agenda, I'd like to just bring forward to you some of Professor Soottawat's highlights in his career. So back in 1997, when he first received his PhD in food science and technology from Oregon State University, he has went on ahead to publish more than 800 research articles in peer-reviewed international journal, which we indexed but in the Web of Science. He has also won several awards over the last 24 years, including the top 1% of researchers for most cited documents in the field of agricultural sciences, awarded by Clarivate for 6 consecutive years. He has also established International Center of Excellence in Seafood Science and Innovation at Prince of Songkhla University. He has also appointed in multiple editorial boards, including Journal of Food Biochemistry since 2000, Fisheries Science since 2015, and he also served as the Associate Editor for International Aquatic Research since 2010. So that's a really good highlight under his belt. So now, without further ado, I would like to introduce you to Professor Dr. Soottawat Benjaku. Over to you, Professor. Can professors hear us?
Thank you for kind introduction. Good morning, good afternoon, ladies and gentlemen. First of all, I would like to thank Cultivate Analytics for inviting me to join the webinar. It's definitely my honor and privilege to share my experiences with our participants today. And I want to share my slides.
Yeah, Professor, on top of the bar, if you can see share.
No, not this one.
Yeah.
Not this one.
Or if there's a shortcut key, if you can do a Control Shift and D, that works.
Okay. Okay, I got it.
Yeah, I can see your screen now. Thanks.
All right. Oh, sorry for some technical problems. So again, I would like to introduce myself. Okay. So my name is Sutawat Benjamin from Phnom Songkhla University. I'm a professor in food science and technology, and I'm the director of International Center of Excellence in Seafood Science and Technology. And I have been named as the highly cited researcher for 4 consecutive years by Cultivate Analytics. And this brings me to join this today's webinar. And this is my publication status, H-index, number of publication, and number of citations.
Sorry, Professor Soottawat, we're not seeing the presentation.
And can you hear me?
Yes, we can hear you, but we are seeing your file browser.
Stop sharing.
Okay, perfect. Thank
It's
you.
okay right now?
Yes.
Sir? Yes. All right. So this is my profile for 20 years, start from 2001 to 2021. And of course, those kind of papers are from my researches. So I can divide my research into 2 major areas. The first one is seafood safety and quality. The second one is utilization of fish and shellfish processing byproducts. And this fit well with the BCG economy models. And zero waste is part of the circular economy, which aim at fully exploiting low value added leftover by transforming them to the value added and marketable products. And to make you understand more that I'm gonna subdivide my area. The first area I'm gonna subdivide into two subdivision. The first one is child attention and lowering the quality losses. So we have been conducted the research on the child extension for a long time ago using like a plant extract and natural additives. And also we use the non-thermal processing technology. That because this technology doesn't like change much on the quality attribute of the seafood, particularly for the raw fresh, like sashimi, for example. So we have paid attention on this technology so far. So, and also we interested in the indigenous enzyme associated with quality losses, like polyphenol oxidase, proteases, trimethylamine oxide demetylase. Let me show you one thing. You can see from the right-hand side that if you keep the shrimp or crustacean for 3 or 4 days or more than that, you can see the black spot on the head portion here. And the consumer normally consider as the spoilage caused by microorganism, but in fact it's triggered by biochemical reaction mediated by polyphenol oxidase or tyrosinase. And to solve the problem, to solve this kind of problem, they have some like commercial PPO emitters named 4-hexylresorcinol, actually is extract from the fake, but still costly. So since from the structure, you can see that we have phenol structure. So we get the idea that why don't we exploit those type of phenols from the plant in our country. Thailand is one of the countries that have the diversity of the plant. So we start from the leaf with have the use as a for medicine or as a food. For example, chamomile leaf, the goa leaf, green tea leaf, or castor apple leaf. And what happens is when we extract using ethanol, we found that the extract very clean one. So when we treat the trim have the discoloration. So to solve the problem, we have to remove the chlorophyll. But previously, we used chloroform to remove chlorophyll. However, chloroform is toxic substances. So we developed this kind of sedimentation process by understanding the molecule of chlorophyll and also the solubility characteristic of this compound. So we end up with this kind of sedimentation process, which can consider as a green process. And to enhance the ability to of the polyphenols to inhibit the PPO, we also use the ultrasound, which is one of non-thermal processing technology, to just push those kind of compounds through the shell. And you can see this is a pre-cooked shrimp and keep for 10 days at 4 degrees Celsius. You can see the control one, you can follow the analysis at the head portion, also the leg and the tail first. However, for the one that treated ETCG, which is a major component in green tea, along with the aid of ultrasound, we cannot see any black spot here. So this is confirmed that this kind of compound effectively inhibit the PPO, and also we can prevent the malice effectively. And apart from the extracting the leaf, we also focus on the agricultural waste, particularly coconut husk, because you can imagine like in some island or some part of Thailand, we have a lot of the coconut tree, and this is byproducts. It's a huge, a big pile of the coconut husk left over, and maybe you can burn it. And actually, this kind of can be served as raw material by using ethanol for extraction, and the extract had the high antioxidant and antimicrobial activities. From here, you can see that after treated the spoiler bacteria, Pseudomonas, and also other pathogenic bacteria like Vibrio or Escherichia coli, Listeria, Monocytogenes, and Sepsis aureus. And you see that after treatment, the cell is kind of become poor or shrinkage, and finally, it's caused the death of the cell. And also, apart from those kind of plant origin extract, we also use those kind of byproduct like a squid pen or shrimp shell as a source of the keto oligosaccharide or COS. And these compounds also have the high antioxidant and high antimicrobial activities. And these are the images of the cell of the Pseudomonas, which I mentioned that is a kind of major spoiler bacteria. When we treat the COS, it's kind of like have a poor and shrinkage and also die finally. And that, apart from the study at the lab scale, we also like develop those kind of additive for industry. This is one of my success success story of my research. Actually, so we developed the phosphate and bicarbonate replacer for the shrimp industry. You can see from here. Actually, basically, phosphate have been used for a long time in the shrimp industry. That's because they can uptake water, and you can see after cooking, the one without the treatment, they kind of come in dry texture and it kind of shrunk like this. And after treated with mixed phosphate, you can see those kind of like they can uptake some water, so the weight gain is around 10%. And when they cook it, the cooking loss is around 13%. While still have cooking yield around 95%. But for us, for our formulation, we call phosphate and bicarbonate repressor, we can get like a weight gain around 10%. Why? We come up the cooking yield 100%, which is higher than mixed phosphate, and also cooking loss is higher, lower than the mixed phosphate. So this kind of success story for us to develop this kind for industry. And also we get the IP Champion Award from the Ministry of Industry for this phosphate and bicarbonate repressor. All right, so apart from additives, I mentioned that we also focus on non-thermal processes for seafood processing and preservation. Start from the after capture, we try to lower the microbial load using the electrolyte oxidizing waters. And in addition, we also try to use a several kind of technology like modified modified packaging, co-plasma technology, pulp electric field, and also high pressure technology together, and in order to extend the shelf life of the seafood and seafood products. And this is the equipment we have, like pulp electric field, co-plasma, ultrasonic processor. And one concept that we keep in mind all the time, that hurdle technology. So it means that we try to combine additive that we produce in our center along with this kind of non-thermal technology or other technology to lower the growth of microorganisms, particularly for spoilage and also pathogen. And as a consequence, we can extend the shelf life for a long time with the plant quality. Right, so I'm going to go to the other topic, that functional property of seafood protein. As you know, the protein is a major constituent in the seafood and seafood product like a fish. You can see that when you take a fish fresh, that the major component is protein. So we focus on gelling properties of the surimi of fish means from tropical fish. We also study on the film formation with emphasis on the edible and active packagings from fish muscle protein and also gelatins, and also emulsion and foam ability from fish and mollusk protein. This is gel. So what is mean gel? Gel is not mean like the gel that put on the hair, to fit the hair in the shape. No, actually the definition of gel, protein gel is mean that the three-dimensional network that can connect each other by bosom bonding, and by water inside, you can see from like a fish bowl, the good quality fish bowl, you can see that when you chew it, it's kind of moist in texture. And also, like maybe you're familiar with this one, imitation crab or crab stick that also produced from surimi. In Thailand, we have been used several kind of fish. The majority one is a tredfin bream, big-eye snapper, and also we can use croaker and lizard fish. And this is the first fish that I in my research experiences we conduct on the surimi. It's named big-eye snapper. In fact, they have two species, major species, and one is have good quality one. This one, the right-hand one. And so that's why we, as a scientist, we have to figure out and find out that what happened. So we study gel mechanism, we study proteases or enzyme proteases, which is undesirable because they can cleave the peptide bond. And also we study the good enzyme in the surimi named transglutaminase. So the trick is to inhibit the protease as much as possible and maximize the good enzyme as much as possible. And also, it's our job to just improve the quality of the surimi from the poor quality fish like this. All right. As I mentioned, the protease is undesirable enzyme in the surimi. So we need to find out and search for the alternative protease inhibitors. In fact, in industry, they can use the egg white. They can use whey protein isolate imported from abroad. And so we have abundance of the resources. So we search for the alternative additive protease inhibitor like a protein isolate from indigenous legume seed like bambara groundnut. This is indigenous in the southern part of Thailand. And also tuna roll, squid ovary, duck egg albumin, for example. And simultaneously, we also improve the gel property by enhance the cross-linking of protein using the polyphenol. You can, as mentioned previously, we focus on plant polyphenols. And you can see from here, polyphenol after under-oxidation, they become quinone, which is electrophilic, and they prefer to receive the electron from protein here. And finally, they become the bridge, a link between two molecules of protein. So from the TM images, you can see that after we add the extract from the coconut husk, and you can see at the higher amount, the aggregation can be formed at a high extent when compared to control one. So this confirmed that the phenolic compound from the natural sources can work as a cross-linker. And also for surimi gel, nowadays, a number of the consumer consider health promotion. So we also add some ingredients that have been known for the health promotion. For example, virgin canola oil, they have the medium chain fatty acid, beta-glucan, and actually beta-glucan also have been health promotion. But in terms of food science, they also function as stabilizer or emulsifier, so that might be mixed together, and they can help to stabilize or double throughout the surimi gel. And also we can increase the health promotion by adding external ingredient like a psyllium husk powder in the gel. However, this one must be optimized because addition of non-protein into the muscle protein like surimi, they can affect or negative effect on the quality of the gel. And move a bit more to biodegradable and active packagings. So the example that we have done, we use a gelatin film and seal it like a pouch, and this inside is the oil, and this is like a seasoning. Like when you buy the instant noodle, they have to pouch it like this, but you have to tear it out and like put in your noodle, right? But for us, you see that after we add the boiling water for 15 seconds, those kind of pouch is totally dissolved and release this kind of oil and also seasoning into the water. So we don't need to look for the trash bin to throw it away the plastic bag or pouch. And this we get the silver medal from the 42nd International Exhibition of Invention in Geneva, Switzerland. And currently, we also work on the nano-spun fiber based on PLA, polylactic acid, chitosan, also gelatin, containing active component that I mentioned previously, like COS or the plant extract. However, normally the solvent they use is kind of toxic, so now we try to search for the safe solvent to use to develop those kind of nano-spun fiber. All right, so this is very important thing that about the utilization of fish and fish processing leftover, with emphasis on the nutraceutical, cosmeceutical products. And I would say that we have 5 major products in our center right now: hydrolyzed collagens, biocalcium from fish bone, shrimp oil free of cholesterol, chitosan, chitosan derivative from shrimp shell, digestive enzyme from fish viscera. Okay, let me explain you a bit more about the first one, about fish skin. Actually, there are several kinds of the skin generated during the skinning process. And you can see this from big snapper, unicorn leather jacket, even squid skin, we can use it. And also we can use scale as a source of the collagen. Okay? So actually in the market, the hydrolyzed, actually collagen is a large molecule and it's kind of difficult to be absorbed by the body. So hydrolyzed collagen, which is have much smaller molecule in size, so has drawn attention by consumer, and it have been known for skin nourishment, for beauty purposes, for bone strengthening. So this one have gained attention from a lot of consumer, and you can see in the market a lot of money. But I would say that most of the collagen, hydrolyzed collagen in the market produced mainly from fish scale. That's because they don't have the fish odor. So the fish odor in the hydrolyzed collagen from the fish skin is kind of challenging for us, to tackle the problem. So this is the hydrolyzed collagen from the acid sea bass skin, and we also consider as a functional ingredients. As I mentioned, the hydrolyzed collagen or derivative from collagen from skin have the fishy odor. So we need to solve the problem. So we developed the one technology by using the combination of different kind of technique we call power electric field to just make a pore, small pore in the skin. You can see the cartoon here. After we pre-treatment with the PF, they have the small pore here, and then we put in this kind of vessel and then add the enzyme and then apply vacuum implantation. So during vacuum apply, those kind of like air suck out, and while we release the vacuum, those kind of lipase can get through the pore into the skin and hydrolyze the lipid effectively. We do for cycle, and you can see from here that the initial skin, they have a lot of the fat distributed throughout the skin here. We stain with the 9-blue-A. After we treat with our technology we develop, you can see the negligible the fat in the skin. And after we produce hydrolyzed collagen from our skin, you can see the red bar. This is a hydrolyzed collagen produced from the skin that treated by our technique or technology we develop. We can see the lowest, the fishy flavor and the fishy odor, and they have the lower score than the one that treated solvent, isopropanol, and also the control one. So this one can solve the problem of the fishy odor produced from fish skin. And hydrolyzed collagen, have been known for skin nourishment. I mentioned, particularly when we use in conjunction with the ascorbic acid, like a 2-to-1 ratio. You can see that they can induce proliferation of skin cell, fibroblast cell. You can see that those dependent. And we confirm that with the using of hydrolyzed collagen together with vitamin C at 2-to-1 ratio, they can induce the production of collagen in the skin cell. So this is good for skin. And also we also use the skin cell, to test for wound healing. You can see this is scratch of the cell that we see that in the sick well. And then after we treat it with the hydrocollagen at high level, you can see that the scratch is gone. It is disappear like this. You can see this is a very low one. Okay, so this also confirm that hydrocollagen can induce the wound healing. And most important thing that normally right now the hydrocollagen is suggested, but for elderly to take those kind of 1 spoon in the like a sample in the drink. And what happens is once we we see the whole osteoblast cell is a bone cell, and when you add the hydrocollagen, you can see this guy like a small dot here is like a calcium nodule, and it means that after we add the hydrocollagen, they can induce the proliferation of the osteoblast cell and also induce the cell mineralization. So you can see here those kind of graph here. And since the hydrocollagen might be like undergo loss in the activity, so we develop those kind of vesicle we call liposome is by layer of phospholipid and load the hydrocollagen inside, and we freeze dry it and also like put in the aluminum foil, and we can keep for longer times. And when we want to use it, we just dissolve in water because it can dissolve easily in water. And we can, this kind of prototype that we can pack in a high capsule and in the blister pack for easy, a portable one. And this is kind of like a commercial product. So one company licensed our petty patents to produce shot drink, and this is a commercial product they launched in the market right now. And we also focus on the cosmeceutical and work in cooperation with the one faculty members in the pharmaceutical science faculty, and we produce a lotion, serum, and a cream. And what happens is we have 30 volunteers apply serum for up to 4 weeks, and they apply every day. And you can see this lady, after 4 weeks, the number of pores is reduced, and also the skin is more moist. And the same with this lady. Okay, so this is somehow that they have the way to just develop more. Now, just move to Fishbone Calcium. These are those products we have licensed to some SME and also entrepreneur. And you can see from here, if you visit the tuna can industry, you can see this guy bone after the meat separation. So after we get the bone, this is smell sting and also dark color. We have to clean it, treat it with our process and drying, grinding, and sieving, and come up with the bone, tuna bone. And what happened? What the advantage of the biocalcium? You can see from here that biocalcium, after we subject to a gastrointestinal tract, and we pass through monolayer couple monolayers, and we found that the biocalcium with a collagen inside, they have the higher bioavailability than a calcite bone. Calcite bone is in bone that's subject to the high temperature at 900 degrees Celsius for 6 hours, and also they higher than the commercial calcium available in the market, like caltrate or calcium lactate, calcium citrate, for example. And this is an example of the prototype that we can put in the high capsule or like a blister pack for easy for the to bring it. And we can fortify in the biscuit, for example. And this work, we got the silver model from the 45th International Exhibition of Invention in Geneva, Switzerland as well. And also we get the special prize from Korean Invention Promotion Association in the same event. And this is interesting for us right now. Is the shrimp oil from hepatopancreas and cephalosporins. This is the hepatopancreas located on the head of the shrimp. So actually, this is kind of byproduct from some main product. So some main product, as mentioned, is that the whole shrimp without hepatopancreas. So the industry must have the vacuum sucking machine and suck this kind of hepatopancreas out, and this can become a waste or byproduct. Basically, they just use a fertilizer. They don't know that actually it's an excellent source of oil and also astaxanthin. You can see from the color that the oil have the orange color. This is the original one, but I try to make the illusion to make you see the orange color. So this is the representative astaxanthin. Okay, and now we start the cooperation with the one company to produce this kind of oil. And when compared with the astaxanthin between the oil from the cephalosporins and hepatopancreas, this one from hepatopancreas have the higher astaxanthin when compared with the head or cephalosporins. Okay? And astaxanthin can have gain attention because they have the very high antioxidant activities, around 100 times higher than tocopherols. And to protect those, since they have the high PUFA like the EPA, DHA, so this kind of pronunciation. So we develop those kind of technology like in microencapsulation and also nano liposome. And recently we also developed nano chitosan polyphosphate gel. You can see from here, basically, if you add the oil in the water, it's kind of float on the top. But with this kind of technology, this kind is more nano size, it's got dispersed throughout the aqueous phase like this. And for the microencapsule oil, we fortify the bread. We can add up to 3% without the changes in the sensory properties. However, at 5%, it change the color and also the smell. So that's why the 3% is recommended to fortify in the bread. Also, okay, move to the shrimp shell. For shrimp shell, also one of the byproduct from the shrimp processing plant, and we are still focused on the chitin chitosan derivative, particularly for chito-oligosaccharide or COS. To enhance the activities, we also study plant polyphenols, chitosan, or COS conjugate. And for this project, we focus mainly on bioactivities, including antioxidant activity, anti-inflammatory activities, anti-obesity, and atherosclerosis also. And in terms of food additives, we use antioxidant or antimicrobial agent. And lastly, for the byproducts, we have been done for a long time on the fish enzyme, particularly for trypsin or pepsin from tuna industry. So among all the organ, the spleen is an excellent source for trypsin. And we also use trypsin as a digestion aid for elderly, because of when people get older, those kind of digestive system is kind of become worse. So unfortunately, trypsin, when you go through the stomach with acidic in pH, is kind of like inactivated. So we have to encapsulate it. So we use the arginine together with a low molecular weight chitosan. And this is the bead. This is the microstructure. And after they pass through the simulated gastrointestinal tract, the activity still retained. So it means that when they can pass through the stomach, it survive, and they can act active at the intestine or in intestine portion. All right. So that's all the researchers. Actually, there's some more. So I cited, I list the most top 10 paper that I cited for my life, actually. So you can see from the highlight, the bone one. Normally, the one that people cited from my research is protein hydrolysis, collagen, gelatin film, again, protein hydrolysis, essential oil. Also, again, edible film from fish gelatin, collagens, gelatin film again, phenol compound, muscle protein. All right. This is during the 2001, 2021, 20 years. However, before that, I also have the high citation for some paper. This is part of my thesis when I studied at Oregon State University in 1997. And also this one, this work is not part of my thesis, but I did because I love to do that. Okay, so I also wrote the paper and submitted to the journal. Right. So in conclusion, that the topic that I have a high citation is being protein hydrolysis, collagen, edible film, fish muscle protein properties, phenol compound, and essential oil. And how to make the can publish a lot of paper. So you must have manpower. So graduate student and postdoc fellow is very important to help you to work and publish a paper. Of course, you must have money to run experiment, and you must have facility. In case you lack of some equipment, you can have the cooperation of build the network with other team or other university in Thailand or also outside Thailand, and keep writing and keep submitting their manuscript to the peer-reviewed journal. And how to make the people cite your paper, I think it's depend on luck also, because it's depend on topic, content, and also the trend of research. For example, right now in our field, functional ingredient is very popular, and also nutraceutic and edible film and also active packaging also still in the trend right now. And lastly, I think that good writing also important to make the reader cite your paper. So your paper must be readable, clear, and straightforward. And in terms of a graduate student, since 2000, I supervise 54 master students, 50 PhD students, and among 50, 20 from India, one from Bangladesh, one from Vietnam, one from Nigeria. And currently, I have the 3 PhD students from Thailand, 4 from abroad, 1 from Indonesia, 2 from India, and 1 from Egypt. And each PhD student have 5 to 12 ISI index papers. And this is facilities I don't have much time to go through. And of course, we must have grant. And luckily, this year I get the big grant, Chair Professor grant from NASDA in cooperation with the between the Prince of Songkhla University, Chiang Mai University, Chulalongkorn University, Thaksin University, and also biotech. And also I have the support from NRCT, National Research Council of Thailand, under the program we call International Research Network with University of Manitoba in Canada. And also I serve as visiting professor in China, co-class professor in Indonesia, and we have corporate co-publication with some university in China and other countries as well. And as a professor and also scientist, we have to contribute to the academia and also industry. So I have written a book chapters, more than around 20 of them. And also recently I contribute as a keynote speaker or invited speaker. Last year, I have 2 events as a keynote speaker in Indonesia by webinar. And next month in China, one in China, and the other one in Indonesia. And this is a webinar on the 28th of July last month, organized by Yusuf Kacamada, Yogyakarta, Indonesia, and these are participants. And the last slide is once we have the knowledge, we have the know-how or technology, we have to transfer to the user or industry or SME or entrepreneur. So after discovery, we come up with the license and license or patent or intellectual property, whatever you can say, and then transfer to the user. So we have 3 products that heavily transfer or license to the industry. The first one is hydrolyzed collagen, the second one is fishbone calcium, and phosphate bicarbonate depressor. All right, so thank you so much for your attention. I think the 30-minute sharp, right? Yes. Thank you so much.
Yeah, we have a good number of audience today. So if you have any questions you want to pose to Professor Soottawat or any other panels, do use the Q&A functions. Thank you, Professor Soottawat, for sharing some of your breakthrough research. I'm sure that these findings will inspire some of our audience today to start their own research in respective field. So the next question is, however, that how do you find the right partner? I will now have Julin, who is the regional solution consultant, to share more on this. Over to you, Julin.
Thank you. Thank you, Professor Soottawat, for the great session. I think I got very excited with some of your commercial products, especially the one about the collagen serum for the face. Makes me want to try it now. Yeah. So for my segment coming up, so let me see. Casey, can you give me the presenter rights, please? Thank you.
Sure.
Yeah, so for my session now, I'm keeping my video off because my computer is not working very well with dual video plus presentation. So do bear with me. Okay, so let me just share slides. All right, so can you confirm that you can see? Oops. Okay, so I have my screen here. Great. So thank you again, Professor Soottawat, for the exciting session. So my segment today, I hopefully can be as exciting as yours. But what I wanted to bring to the audience today is to give you some ideas on how to bring your research from ideation to outcome and eventually be as successful as Professor Soottawat in making byproducts into gold. Right? So in today's times, researchers there's an increasing need to explore opportunities to drive societal and economic development through your research. And that is one of the major challenges as researchers now. And not just that, you will definitely have challenges of limited research funding that spurs the need for research focus on real world outcomes. And also technology transfer needs to be accelerated and also socially responsible. So in the next few slides, I will be using an example to help you visualize the steps as researchers that you can take to bring your research from your idea to a commercial outcome. So let's assume you are a food science and technology researcher like Professor Soottawat, and you're looking to convert what could be seen as waste, to something of potential commercial value, turning that into gold. And Professor Soottawat mentioned one chemical compound called astaxanthin that he extracted from the shrimp head. Okay? So astaxanthin is actually a pigment that can be extracted from a variety of different organisms, and one of them is shrimp. Okay? So as a researcher, you might want to start exploring the research landscape of astaxanthin by using a research discovery tool called Web of Science. And from this exploration, you will see that most of the astaxanthin research or extraction methods come from algae. So now what you want to ascertain is the novelty of the idea that you have, meaning the idea of extracting astaxanthin from shrimp. So you can refine your results further to those specific to shrimp. And you will see on this screen here that the results has shrunk considerably. This is also an indication that this niche area is something of promise. So you can further analyze your result set by looking at the publication trend and the citation trend in this particular niche area. On top of that, looking at more details, you are able to look at the existing countries as well as institutions in this particular research area and explore the literature to gain ideas. So when it comes to ideas and research discovery, so let's say, for example, you come across a research paper like this one. I always like to call this my Eureka paper, the paper that sparks an idea for me. So through this research discovery process, you might come across an application of astaxanthin. How can this particular chemical compound be used in other products and so on? So in this case, there was a paper that mentioned that there's free radical scavenging and cellular antioxidant properties of astaxanthin. So it could imply that there can be pharmaceutical outcomes for this particular area of research. So something around life sciences. And this is the very first step to exploring the downstream potential of the compound that you are exploring. So what can you do from here as a researcher? Because you might be an expert in your own field in food science and technology, okay? But making this into something of pharmaceutical use requires collaboration. You would probably need to leverage on the cross-discipline experts like those that are doing specific research on antioxidant or free radical scavenging. Okay? So how would you identify these partners? Because not all partners or collaborators are suitable or the best choices. So using tools like insights benchmarking and analytics, which is Clarivate's citation-based research analytics tool, it will help you to make decisions on potential collaborators based on their research performance, impact, and profile. So you can use a custom data set that you find from Web of Science around free radical scavenging publications to get information about the top countries to collaborate with, and also the top institutional choices for collaboration. And all these can be based on a set of indicators from insights that will help you to create a profile of your target collaborations. And with that, you will then be able to evaluate and identify the top authors in that area and make informed decisions on their suitability based on their research impact and performance using one of our latest tool called the Author Impact Beam Plot to ascertain their performance in recent years. So all that said, once you have acknowledged that there is a potential downstream outcome for astaxanthin. Okay? What about commercial potential? Because commercial potential is still part of that downstream impact that you want to explore. Okay? Can astaxanthin be turned into something, into nutraceutical product? Can it become a nutritional supplement? Okay? So you can explore the potential of astaxanthin. You can use a tool that we have called Cortellis Drug Discovery Intelligence that will empower you to make go or no-go research decisions with speed, confidence, by tapping and analyzing critical R&D data from a single platform. So within just a few clicks, just searching for free radical scavengers, you will be able to easily access and analyze key scientific information and insights to prioritize development candidates, identify potential targets and experimental models, and assess the competitive landscape earlier than any drug R&D database. You can also identify novel biomarkers and validate established biomarkers by linking information from drugs, targets, and genes to information from a variety of sources. So ultimately, this is like your encyclopedia and data bank for the chemical information that is required to help you ascertain the potential of this landscape of free radical scavengers. Okay? Now, as there's many drugs with the mechanism of action of free radical scavenging, okay, there are many drugs that have this antioxidant effect. But how about exploring whether any of these have actually used astaxanthin as an active ingredient? Okay, that is very important because astaxanthin is an active ingredient and you want to ascertain whether that has any potential in its application in drugs. So you can use our database to search for this particular application, and you might come across only one drug. Okay, so one drug that is in preclinical phase that targets coronary artery disease. So with that said, let's look at the flip side of the coin, meaning astaxanthin could be used as an active ingredient in other drugs besides those that have free radical scavenging properties. Okay? So what are these drugs? So by searching this CDDI, you will also be able to see that there are 3 drugs currently in the pipeline that uses astaxanthin as an active ingredient. So together with the information from the previous slide, you can then infer that with few drugs using astaxanthin as an active ingredient and only one drug in development for cardiovascular diseases, there is little competition and therefore higher potential for this active ingredients application. Okay, so if you're in this research area, it becomes more evident to you and clearer so that you are able to justify that, hey, this is an avenue of potential, there could be downstream effects, and I want to continue to pursue this particular application. So then the next thing that you might want to include with, from your tech transfer office. So together with your tech transfer office colleagues, you might want to explore the competitive landscape of this therapeutic area or even this drug. So if you want to develop like a nutritional supplement using astaxanthin, look at the competitive landscape. Okay? Using Clarivate's other tool called Cortellis Competitive Intelligence, you will be able to easily look broadly at what is the overall landscape across the end-to-end process from early research discovery stage all the way through to market. It can help you see the full picture via a single integrated platform that houses the most comprehensive and granular drug pipeline information, along with related clinical trials, deals, patents, milestone, regulatory designations, sales and forecasts, SWOT analysis, and actually many, many more. Okay? So the screen grab that I have on the screen on the slide here just gives you a snapshot of the number of drugs, the number of active drugs that are in pipeline now, the number of companies that are in this space of free radical scavengers, and also the countries. So in one landscape view, you will be able to make competitive decisions around whether you want to pursue this area or not. So let's say you are working on drugs with the action of free radical scavenging and its application to cardiovascular diseases. So you're limiting down to just vascular diseases alone. And you want to know who are the people working in this space, which companies, what are they working on, how are they progressing, how are your assets different from what they are doing, because you need to be a differentiator in order to become something of value. So this will then give you an indication of your success probability given the current competitive landscape. And going further to explore ongoing clinical trials in that specific therapeutic area will also allow you to understand the clinical protocols, biomarkers, and success rates of those trials and learn from them. Patent information will also be important to check on the patentability of the technology your team might be working on. And then another important consideration around whether you are looking to position yourself for interest for investors. Okay, do you want to look for investors? Then use the same tool to look for existing deals out there and see which corporate players are open to academia collaborations and how the deals are transacted. Some of this deals information has monetary values indicated. So you will be able to quickly see what is the potential funding that you might get if you have a corporate partner. So with all these information at your fingertips, the tools that I presented to you, you can now bring your research from idea through to cross-discipline collaboration and ultimately lead to commercial and social impact. The holistic focus and scale of Clarivate's capabilities provides end-to-end data-driven insights to support multiple stakeholders and enhance value. And we now have an exclusive and transformative portfolio of unified solutions to help researchers and institutions further accelerate their innovation and product lifecycle from ideation through to outcome. Clarivate has the richest and widest collection of synergistic data sets that underpin our best-in-class interoperable solutions. So we look forward to working with you in partnership to bring the most potential out of your research work. We are open to discussion, so the contact details will be reflected at the end of today's webinar session, and I hope to work closely with all of you to make your research a success. So thank you very much, and back to you, Casey.
Thanks, Julene, for demonstrating the technology that our audience can use to develop your idea. So next item, we're almost on top of the hour, but the following agenda may be the best part yet, and it's Q&A. We receive a lot of questions. We would like to address them one by one. Note that the estimated session will last for 15 minutes to up to 30 minutes. We are mindful of your time, and we are glad to have you stick around with us. But if you have other engagement that you'd like to leave and attend to, you can always review the recording again. So now I'd like to invite another colleague of mine, In Bank, who is the Director of Government Strategy and Engagement Division for ASEAN, to moderate our Q&A session. Over to you.
Thank you, Casey. Professor Soottawat, thank you for your exciting presentation. It's very insightful. Now, the objective of the current Q&A session is to take us back to the beginning of your journey as a researcher. And the aim here is to allow many of the young researchers in the audience today to learn, to gain insight, to be inspired by your amazing journey of achieving excellence, becoming the world's most influential mind in your field, as well as driving innovation and deliver socioeconomic impact. Now, the first question for you is going back to your PhD dissertation that you submitted in April 17. Remember that day, 1997? Now, the title of the dissertation is Utilization of Rays from Pacific Whiting Surimi, Manufacturing Proteinase and Protein Hydrolysate. Now, can you share with the audience the most important aspect of your PhD training, and how does that experience shape your research in the coming years?
Okay. Thank you. Can you hear me? Can I share?
Yeah.
Can I share screen?
Yeah, you can share
Okay.
screen.
Just give you. Okay. Can you see? Can you see it?
We are just seeing your folder now, your file folder. You may need to open that PowerPoint.
Okay, so you can see right now, right?
Yes.
So that one get back to 1994 is mine like almost 7 years ago, you know. So I decided to go to United States that time. That because I think they have the system like Thailand and Singapore, because they have the courses, and also at the same time they have dissertation. So I can learn both the basic knowledge and also like you know, the way to practice to be like a conduct experiment at that time. So I decided to go there. So unluckily we don't have the website like this, like the fantastic website, like a web website like this. So we don't know anyone. So we just do go to my library, search by myself to just hard copy and see the paper. Okay, working on the area of the seafood, because I'm working in the southern part of Thailand, where a lot of the seafood processing plants are located, and we had a lot of farms. So that's why I also want to work on that one. So I decided to go there. And at that time, I luckily I got the Fulbright scholarship, you know, to study for 3 years over there. And I also select the university. So finally, I come up with the Oregon State University. So at that time, you know, after I finished courses, I went to the seafood laboratory we call OSU Seafood Laboratory that time, and they have one project going on the passive whiting. This fish. This fish actually we cannot cook it, because when we cook it, it's turned to be liquefied. I mean, it turned to be liquid, so no one can use it. But believe it or not, this species now has become very important raw material for surimi production in the world, apart from Alaska pollock. You know, maybe you have heard about Alaska pollock. This one was one of them that very important surimi. That because, you know, they solve the problem, because these fish, they contain a high amount of catechin L, which is the heat activated proteases. So they solve the problem by add the protein additives in that time to kill those kind of proteases, and they can produce the good surimi. All right. So that time I did not have chance to work on the surimi gel that I mentioned. That okay, one of my part of my research, but I just observation, you know, so observation, learning, but you know, so but I have no chance to do that. So my advisor told me that okay, you can do whatever you do, you know. So I am thinking that okay, because during the the production, there are a lot of, you can see that a lot of waste generated, including frame, head, or anything like that. So it's better to utilize it or recover some the active component there. So for solid waste here, I also decided to go through protein hydrolysis one. At that time, you know, back to 25 years ago, not many research working on hydrolysis like now. So the people focus on peptide, you know, active peptide, and then or thing from plant origin, from animal, from fish, anything like this. No, not that time. And also for liquid waste, you know, I also, you see, during the washing process, if anyone have a chance to visit the surimi plant, one process is washing to improve the colors, and also they watch those kind of enzyme. So if we wash it and throw it away, why don't we recover the proteases from the wash water and utilize it? You know, for example, use like a meat tenderizer, for example. So that come up with the idea. So I would say that during my study there, I have to be independent researcher. You know why? That because my advisor, he is the director, administrator, you know. So he go out every day for meeting, never stayed in the lab. So I have to survive. At the meantime, at the same time, I have to just learn because I have major goal to just go for study to earn the knowledge, not just for fun. So I need to just learn and try to observe, and some of them, as I mentioned, that some of them apart from my thesis, I asked my advisor, so I want to learn some technique, you know, and since then I still using some technique like protein hydrolysis right now. I still working also on that one, but more in depth, because when we gain more experiences, we grow up more, we have we have more knowledge, experiences, we can implement it more like this. And also proteases as well. I also have a lot of project on proteases and also inhibitors. You can see, you know, so when we gather or collect the knowledges, I believe that it will be useful. So it depends on you how much you can gather knowledge during study and also during your career part. Yes.
Thank you very much. Thank you. If I may just quickly summarize, the important aspect that you've learned is you need to be independent, you need to be observant, observe, identify opportunity, especially in terms of when you look at the production system spot where there are any wastage that you can optimize, turn it into high value product. Don't be afraid to ask, explore, and focus on learning and acquire knowledge that will help you in the future.
Yeah.
Does that summarize the experience?
Yeah, excellent. Yeah, excellent. Summarize.
Thank you. Now, the next question, there are a lot of questions that came in through the Q&A chat session. I think I will address them at the right point. But rest assured to the audience, if any of the questions left unanswered, we will share that with Professor Soottawat. He will reach out to you to respond the specific question that you may have. Now, the second question is, it took you about 10 years to receive your first Outstanding Researcher award in Thailand. Subsequently, you have numerous industry, innovation, global recognition. And to top all this, you are selected to be the Person of the Year Thailand in 2021. Now, that is an amazing accomplishment. Now, looking back, can you identify 3 top factors that you want to share with the audience that contributed to your successes? For each of the factors that you highlight, can you explain why is it important and how it contributes to your successes? Over to you.
Okay. Yeah, thank you for the question. This is very important to be successful, you know, actually. So I think there are 3 factors that you mentioned. The first one, I think the very important thing, that the passion and the goal. Everyone must have the passion to conduct the research. You know, if you just get lazy, then someone forces you to do, I don't think that you can be successful. You have to love to do whatever you are doing right now, and you have to get ready to face any problem and get ready to solve the problem, you know, so to survive on that kind of thing. And another thing is, as I mentioned, major goal is very important. As a faculty members, you know, at the time back to when I start my career after I returned from the US, I also have the major goal. Okay, I'm gonna be promoted to be professor. So how to do that? We cannot get get everything for free. So we have to just conduct experiment, publish paper, because it's criteria. We know that one of the criteria is a number of application and also quality. So how to do that? So again, get back knowledge, experiences. So shape up yourself to be like good scientist or researcher, and then publish the good paper. Because even though you have paper in hand, but the poor quality, the committee gonna kick them out, and you're gonna fail. So I think the passion and goal is very important, along with the mission. Don't forget mission as well. What are you doing right now? Like you need staff, you have to have teaching, you know, research, and also extension. But the proportion maybe is depend on individual, but mission also important. All right. So the second factor is, I think, responsibility. Dedication is very important. You know, if you don't have responsibility for whatever you have, especially for research, for example, you get the research grant from one granting agency, you never turn in the result. You have to be asking every time. So it means that you lose credit, and no one gonna give you again on that one. And how can you conduct experiment? Because without money, without budget, it's difficult in terms of science technology. We need the money, we need the budget. So to be like on the top, you need to demonstrate and prove yourself that you are the leading one with high responsibility, and you have to have dedication of yourself for research. Okay, for myself, actually, all the time, I need to, if somebody saw me, I bring those kind of hard copy all the time with me during like boarding and the airplane and the airport. I have to just edit, So I ask my student to just print out the hard copy, and I have to do edition, all the time. So that kind of responsibility. And the last but not least, I think very important thing is non-stop or continuous learning. This is very important. Learning never, stop. You need to follow up. You need to update yourself all the time. So that's why, you can see, oh, this guy maybe do so many things. But that because I have to observe and learn and search more information. Whenever I visited any university or research institute, I also like observe that, okay, what's going on, what kind of technology they apply. So if I have a chance, I need to learn and understand more. And of course, we have to go for a proposal, like that. So without understanding, we cannot write the good proposal. We cannot convince the grant agency. Okay, so that thing very important, that non-stop learning also important. So now 3 is okay.
Thank you. That's very clear. I hope the audience, I'm sure the audience will benefit from what you have just shared. Very clear 3 important factors. Set clear goals, be passionate, need to be accountable, be credible. The last point is never stop learning. I guess it's amazing. Now, the next question, I observed that while you're sharing, there are easily 4 or 5 research area that you focus on, from functional property of seafood protein, research on improving seafood quality, and also producing alternative additive, and also maximize fish leftover, turn them into value-added nutraceutical or cosmeceutical product, which is higher value. Now, this is related to some of the audience has asked, how do you keep yourself ahead of your research area? How do you decide what criteria do you use when you're making a decision to move from one research area to another? Can you please elaborate? Thank you.
Yeah, actually, this is a good question. Actually, you have to imagine like the whole picture, everything. So in the seafood science, we have to start from the we call after date, the fish date, up to the finished product. You can see from that. So all the steps, you're gonna have the result equation waiting for you all the times. Like for example, if you want to make fillet, what happened? You have to maintain qualities, what kind of technology you can implement it, and the leftover byproduct, what you're gonna deal with that one. And of course, we have to focus on the high.
We lost you, Professor Soottawat. I think your screen has frozen. You're back. You are back.
Sharing. It's okay right now?
Yeah.
Okay. So as I mentioned that, every like a step of the research, you can learn in the meantime. Everything, you just created. For example, when you work on the qualities, for example, functional property of protein. Okay, so we have learned that they have been using like some enzyme we call microbial transglutaminase, for example. So apart from that, can we do other things? Can we use other cross linkers to improve the quality? And in the meantime, at the same time, we can have the health promotion, for example, phytochemicals, for example. So that's why, during working, you just create and study more and try to cooperate it with us. And that's very important thing. And also maybe like some other thing, for example, if you want to go beyond whatever we have, for example, those kind like nutraceutical products, we don't have knowledge yet, actually, frankly speaking. So we need a cooperation with the like the expert from maybe in university or outside university. Like for example, as your colleague mentioned about astaxanthin, about the heart disease, vascular those kind of like heart diseases. You have I myself, I don't have expertise on this one. So now I have cooperation with the Chulalongkorn University on the what they call the cell lines. So here also approved that these shrimp oil rich in astaxanthin also have the excellent in terms of the atherosclerosis disease prevention like this. Right. And also we're going to do animal trial as well. Yes.
Right. So now you have nicely sort of lead to the next question that some of the audience have asked. It is about identify collaborators. Now you spoke or explained a little bit about this academic research collaborators. Now, there are two that before moving into industry, how do you approach industry partner? Whether the approach is different from approaching an academic partner. Can you advise the audience how can one establish strong research collaboration network in the academic as well as the industry? Over to you.
Yeah. That's a good question, actually. Before you inviting the right person, I mean the one, the well-known one, you have to prove yourself also you are the right person as well. Not just you know, you rely on someone. You have to be the one that what they call well recognized in that particular field. For example, like I have Professor Grant, I have to connect other partners from other university because I know that I don't have knowledge. And also, for example, nutraceutical products, we need to finish in vitro, animal trial, and clinical trial. But clinical trial may be the last step because very costly. But for this in vitro, we can connect with the person we know. So we know from where, we know from publication also or personal contact. But mainly, we can introduce by some colleague also. For example, from Chiang Mai University, I have like a cooperation in terms of animal trial because they are the big group, active group. Active, you see the keyword active, so active means that they work a lot and they're productive as well. So we know from their publication, actually, we know from not because of the way they look, but we screen from whatever they have done so far, and they also the right person. They are the one that the leading people in that particular field. So we want to join with these people, not just okay. Someone claim okay I can do that, but in fact we have to check. Right now seriously I have that bad experiences also, but I'm lucky somehow because I try to contact one person, one team, but finally I cross check with my friend and they say, oh don't do that with them because you didn't know anything. So if I cope with them, it's kind of risky because we cannot get any fruitful, like cooperation. That because we don't get the right person. And also at the same time, as mentioned again, we have to be the right person as well.
Right. Now you mentioned about use the publication. From there, you find those who are active in the area that has the skill that you want. You are able to access the impact of their work. Then once you think that you identify the potential partners, you do some checking with your peers, with your own network to assess the reliability of the potential collaborator that you want to approach. Now, and in the tools like what Julian has shared with you is exactly doing that. Is those tools, do you think will be useful for young researchers that do not have very strong existing network as yet? Your comment, please. Can you hear me?
Not clearly. not clearly.
Okay. No, it's okay. No, what I'm referring to is a tool that Julene shared with you, some of the analysis to identify potential collaborators. Will those kind of information useful for young researchers who do not have very strong existing collaboration network?
So I think this is one way very important for the young one, because you mentioned that you start from from zero. So of course you have to, like, for me, okay, let me talk my case. Actually I start from nothing. I never have the lab, my own lab. So I have to just start from the small grant first, okay, and then apart from that, I try my best to just collaborate with some colleague or my friends somehow from the biotech at that time. And once we grow up more, so we get known more. So the people also love to work with us. So that's a very important thing, that okay, don't give up at the beginning. So it means that you have like an opportunity waiting for you as well into a cooperation. It doesn't mean that you have no one. So, but you just contact them and inform them clearly what is our major goal of your research. And since the research is kind of like in what they call the same direction, so you can get the advice from them, or maybe like get like support from them as well. For example, I start this project, but I don't have these facilities. Can I use in your lab, blah, 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 like something like this. So I think they are kind enough to just help you also. And of course, if you just work with them, you have to give the what they call the credit for them by maybe ask them to be co-author, for example, like this. Don't only take, just all, you have to give as well.
All right, thank you. Now, quickly, just to sort of highlight the key points that I've actually learned from you. For young researcher, they need to persevere and always remember to focus on quality, deliver quality work. Quality is ultimate. Now, the next question is relating to collaboration. Now, it's relating to industry partner. How is it different when approaching industry partner? For example, the question that came is, they already use the waste to produce animal feed, for example. How do you convince them to give you the opportunity to work on that waste to explore other opportunity? Over to you.
Oh, and frankly speaking, in Thailand, it's kind of difficult. I'm not sure in Singapore. In Thailand, very, very difficult. And they have a lot of granting agency that require the industry and the partner. They have to contribute like a 20% in cash or in kind. So very, very difficult to convince them. But however, I believe that if you have proved yourself for a long time, for example, from your publication, from what they call the recognitions in the society, that you are a right person, they're gonna accept you. For example, like Fishbone Calcium, for example, that have done. So now we start a licensing to a number of the small medium enterprise and entrepreneurs, for example, and that because they want to utilize these kind of byproducts without value to transform to be the high value products. So this is very important. And also, why I think I mentioned that it's very difficult to cope with industry, because normally as an academician, right? So it's very important for us to keep publishing. But for them, when you start talking with them, they say everything is confidential. You see, everything keep confidential. So it means that no way to publish. So people stop. Okay, so now I think that what I suggested that, okay, you start by the young scientists like this, keep publishing first, and or maybe you can get like a raw material from them. Okay, you don't need request much more from this, but and then try to prove yourself, and you go up to some level, and then that time you are the right time for you to just negotiate with them, and maybe collaborate with them. But at the beginning, don't just jump, because they don't know you. And they don't trust you as well. So that kind of take a long time for career path to reach the point, to reach the successful point. Yeah.
Thank you for that. I think we really overran of time. There's a lot of other interesting questions that come in. Unfortunately, we ran out of time, and we thank you very much for your time. And I am going to pass over for Ree, my colleague, to close the webinar. Thank you very much.
Ree, are you there, Ree?
Sorry, I unmute. Sorry.
Right, over to you, Ree.
Good afternoon, everyone. My name is Ree Pimipasurathi. I am the account manager for Thailand and Laos, and also Indochina area. I would like to thank you very much, Professor Dr. Soottawat, for the informative session. We truly appreciate your making time in your busy schedule. ขอบคุณมากค่ะ And I hope everyone would have an idea about the use of green technology for quality improvement, minimize waste, and develop higher value products for Thai seafood industry. On top of that, I hope you have a clear picture about how researchers can explore collaborations outside their field and ascertain the downstream potential of the research. Also, I'd like to thank you, Clarivate's team, Anamika, Inbeng, Casey, and Julin for making this event successful. Truly appreciate your hard work. If you have any questions, or if you would like to know more about Clarivate's Web of Science, Catalyst, or any of our other services, please contact us. Please feel free to contact me. Okay. Casey, can you put the slide, the contact information slide on?
Sure, I'll do that.
Okay. Okay. You can contact each country's representative. Yeah. In Thailand, Laos, Myanmar, you can contact me. Yeah. By using this contact information. So now it's time. So thank you very much, everyone, for your participation. And last but not least, yeah, please help us improve by completing the survey. It will pop up automatically when you exit the survey the webinar. I hope we'll see you again in upcoming Clarivate webinars. And I wish you all stay safe and have a good day.
Thank you. Bye. Bye,
Thank you so
Professor.
much.
See everyone.
Bye. Thank you.
Thank you.